Hey, let's do some quick differentiation involving the natural log ln. Here, f prime of 3 is going to equal 1 over all that stuff on the inside times the derivative of the inside. So it's going to be 4, I guess that's minus 9 sine of x squared times 2x. You could simplify that to minus 18x sine of x squared, but yeah. So that's what you get, and then you plug in x equals 3. So this will be 1 over, nothing nice over here. Actually, I'm just going to say 12 plus 9 cosine of 9. Cosine of 9 is not a nice value. And then on the top, I guess, we'll have 4 minus 9 sine of 9. Again, nothing nice there. Times, I guess times 6. So actually, I guess I could rewrite this as 54 sine of 9. Yeah. Lovely. Yeah. So that's what we have. Not the nicest looking thing in the world, but that's your answer. Okay. Moving down a little bit, let's look at logarithmic differentiation, right? Where we apply ln to both sides. Now remember, you can skip this step, right? You know that this is going to be ln of the absolute value of cosine of x to the x, and you know that we're going to be bringing the x down here. So why not just skip the step and say x ln of the absolute value of cosine of x? Why not do that, right? Okay. Now we implicitly differentiate to get 1 over y, dy over dx, right? That's always what we're getting on the left side. Do the product rule here, take the derivative of x, it's 1, so I'm just not going to write it. And now this is going to be x divided by cosine of x times negative sine of x, so maybe I'll do this. And I guess we have then that dy over dx equals all this that we had before. I guess this is really, you could write this as x tangent of x if you wanted, times y, which is really just cosine of x to the x. Okay, and that's your answer. So again, note that this is a process, but if you're familiar with the process and you're mindful of your product rule and you're comfortable with your ln derivatives, then it shouldn't take all that long.